In this video, we're going to take a look at the rest of example number 2, which consists of parts F through K. Now, actually, I'm going to ask you to go ahead and right away pause the video here so you can actually go and try to see if you can answer these questions on your own. It's really good for you to try to practice these ideas very quickly, because obviously I'm going to try to make it look as easy as possible, and you want to make sure that you understand what it is you're understanding and what you're not understanding. So go ahead, pause the video here, and see if you can work through these examples. If you're not entirely sure how to do all of them, that's okay. And when you hit unpause, you'll see me work through the rest of the solutions. Okay, so if you spent time working on this, then you should be able to compare your answers to the ones that we have here. So what is the probability that more than 6 customers will sign up for a new card? Got to be a little careful here. If I'm more than 6, that doesn't include 6. So I'm going to only be working with the numbers 7 and 8. So I want the probability that X is going to be greater than or equal to 7. Okay, if those are the numbers that I want, there's a couple ways I can get that. I could find the probability for 7 and 8 and add them together. I could do that with 2 binom PDFs. Or I could go ahead and think about, again, all the numbers that I don't want. And since those are easy to grab with a CDF, I can go ahead and imagine calculating 1 minus the probability that X is going to be less than or equal to 6. Those are the bad numbers. And if I get rid of them, I'll be left with only the probabilities for the good numbers. So this would be like doing 1 minus a binom CDF with 8, 0.30, and 6. And if I go ahead and I crunch out this number, I think I get to a final value of 0.0013. For part G, this asks what is the probability that at most 2 customers, so if 2 is the most, that means I'm looking for these values. This is very easy to find. I have the probability that X is less than or equal to 2. I can find that immediately with the binom CDF. 8, 30, and 2. And I get an answer here of 0.5518. For part H, what is the probability that all but one customer out of the 8 sign up for the card? Now this is one that most people got wrong, so if you end up getting this one incorrect or struggled to come up with an answer for this, don't be too surprised. It really ties back to the idea that we have to understand what X represents. If we don't know that, it's very hard to answer questions like these. So, remember that X stands for the number of customers who are going to sign up for the new card. So 0 customers might sign up, 4 customers might sign up, 6 customers. If everybody but 1 customer signs up for the card, if everybody out of the 8 but 1 signs up, that would mean 7 people signed up. So surprisingly, this is extremely easy. I just want the probability that X is 7. And I can find that with the binom PDF, 8, 0.3, and 7. If I go to my calculator to crunch out an answer for this, I get 0.0012. All right, let's take a look at part I. What is the probability that at least 3 customers? So 3 is the least. That means I want these values. It's hard to grab those individually and add them all together because there's so many, and a CDF can't grab them all at once. But again, a CDF can grab all these numbers in blue that I don't want. So I'll say to find the probability that X is greater than or equal to 3, I'll do 100% minus the probabilities that I don't want, which are from 2 and less. And I can find those blue probabilities using a binom CDF that starts at 8, or I should say has n as 8, p is 0.3, and 2 as the value that I'm going to stop at. If I type all this into the calculator, I end with a final value of 0.4482. Let's take a look at part J. What is the probability that either 2 customers or 5 customers will sign up for the card? So I'm interested in these 2 probabilities. So I want the probability that X is equal to 2 or that X is equal to 5. And so of course to get those, I'll find the probability that X is equal to 2, and I'll just add on the probability that X is equal to 5. that means I'm going to have to do 2 binom PDFs. So the first one would be a binom PDF with a 2. And I would add to that a binom PDF with the number 5. When I add those two together, I end up with a total value of 0.3432. And I'm good to go. Now let's take a look at part K, which is probably the most challenging of all of these different parts. This one asks, what is the probability that anywhere from 3 to 7 customers will sign up for the new card? So anywhere from 3 to 7. That means I'm interested in the probabilities that would be across from these numbers. Well, that can be a little bit tricky because I don't really want to do 5 separate PDFs and add those together, but I also see that the values that I don't want are 0, 1, 2, and 8, so I can't grab all the stuff I don't want very easily with a CDF. Here's one way, though, that I could possibly do this. To find the probability that x is somewhere from 3 to 7, what if I was to first imagine grabbing all of the x values that were less than or equal to 7? Let's just take a look. Imagine I grabbed all of these values here in yellow. Now, obviously, that's way more values than what I need. But now I can see that the values 0, 1, and 2 are the only values out of that I don't want. So I kind of overshade first, and then I can just subtract off the things that I don't want. Notice there's no need to even talk about the value of 8 because I'm only going to grab the probabilities from 7 down and then chop off the parts of that I don't want. Of course, then I could calculate this by doing a binom CDF 8.3 and 7 and then subtract a binom CDF 8.3 and 2. And if I go ahead and I type all this into the calculator and crunch out a final result, I got 0.4482. So that finishes up this particular example. Hopefully you were able to get at least a couple of these correct, and if not, don't be too stressed about it. It just means you might need more practice with some of these ideas. Some of these were a bit more challenging, especially things like the wording on part H, definitely part J, and part K. But if you're able to go to the worksheets and practice these ideas, you'll find this is unbelievably easy to work with. The last thing that we have to talk about in this section is going to be how we find the mean and the standard deviation of a binomial distribution, and we'll do that in the next video.